Good afternoon, everyone. Thank you for taking the time to come to the talk. I know it's the end of a long day, so I appreciate you turning up. Today we're going to talk a little bit about how to use Azure Managed Identities. There's not going to be time for questions. So if you want to make note of one of those ways, it's my blog, it's my Twitter handle, it's my email, just make a note of them. And if you've got any questions, just send them straight to me. I'm happy to answer them. So hopefully everyone's made a note of those. There's a little bit of audience participation in this. So if you guys online and also in the room, you can go to menti.com on your phone and just enter that 8-digit number at the top there. You should kind of get the view of this map, and then if you could just drop down a pin to show where you are. This is just to make sure that everyone's able to access the map. I'll give you a few seconds to check that. Anyone able to drop a pin? Oh yeah, look, there we go. Cool. This is verifying everyone can access it. Okay. Most people from England. Cool. I'm roughly from the same area. Actually, I was born just across the river there, so it's home away from home for me, really. Okay, so we'll move on. Feel free to log on, and the important bit comes later. So my name's Richie. I'm a senior DevOps engineer at a company called Redkite. I've been there about a month. It's great. We're hiring, if you're interested. I've been working within the kind of the data DevOps environment for quite a bit now. And one thing that's really been interesting me lately is kind of the issue around security with deploying applications. Like, I feel that a lot of people kind of see security maybe as an afterthought because there's a lot to know, a lot to understand. Maybe some companies have a security team that kind of are responsible for giving you guidelines, but maybe it's a little bit nebulous. They don't really help with the actual brass tacks of deploying stuff properly. And, you know, some people don't put in too much effort, but a lot of stuff is around, you know, managing secrets. And we all have secrets to manage. We have secrets to deal with. And sort of storing those, I find, is quite problematic. And so Managed Identity is one of those things that I feel that actually go and help some of these problems really quite strongly. Before we get into Managed Identities, I'm going to talk a little bit about the Microsoft Identity Platform, as it's known as, or basically just how security works in Azure. So you've got two parts to it. The first part is authentication. So this is essentially the identity validating that it is who it says it is. So this is typically done through like usernames and passwords, for example, or with enterprise applications, you have a client ID or a secret, and there's other options like secrets and bearer tokens, which we'll get into in a little bit. So like Azure Active Directory is known as the Trusted Identity Store. This basically says that any identities that exist within Azure Active Directory you can trust to log in, and then they're authorized to access stuff. And so this comes on to the second point, is authorization. So once you've authenticated, you are who you say you are. What is it you're actually allowed to do? So in Azure, this is through RBAC, that's role-based access control. Essentially what that means is that there's a role, and then that role has a group of permissions. So a read, write, or whatever. I mean, a popular one in Azure Active in Azure is the contributor role. It's one that's used quite a lot. It's a very powerful role. It enables you to do pretty much anything you want in Azure against a resource, except to assign other permissions. So you find that one is used quite a bit. So identities are assigned a role, and then they can do some stuff. So to really kind of labour the point, if you're staying at a hotel, you've got your key card, that authenticates that you are who you say you are, and then the lock basically determines whether you're authorised to access that room or not. So that's basically the security model within Azure. And we're mainly going to be focusing on authentication. This talk, Managed Identities deal with the authentication part of what identities actually allowed to access. I keep on using this word identity, and it's in the title, Managed Identity. So what actually is an identity? You've got three main identity types in Azure Active Directory. So you've got users, so that's classic username and password. Users can log in, then they're able to access stuff. Then you've got groups, specifically security groups. Security groups, you can add users or enterprise applications to groups, and then those groups can go and be added RBAC permissions against a group of resources or a resource group. And then third and finally, you've got enterprise applications, which you find in the Azure AD tab. So enterprise applications are basically, they're a cloud-based application that exists in Azure Active Directory. And because Azure Active Directory is the trusted identity store, then when you log in using that enterprise application, then it knows that you can trust, or Azure Active Directory knows that you can trust that application, and then it can go and have permissions assigned to it within the Azure resources. So where do service principals fit in this? Because a lot of people talk about service principals with Azure. You know, you need to log into, you need to go and create a service principal. Service principals are basically enterprise applications, and they're also app registrations, which is in the Azure AD tab. So they're all kind of the same thing, but not really, but yeah, kind of. Basically, they're all kind of flagged under the service principal banner. When someone says go and create a service principal, what you're actually creating is an app registration in the Azure Active Directory. That app registration is what secrets and certificates are created against, so that deals with the authentication part. At the same time of creating an app registration, there's also an enterprise application, which is created in the enterprise application registry, and this is what is assigned to roles, so that's the authorization part of it. This is a screenshot of an enterprise application on the left, an enterprise, app registration on the left, enterprise application on the right. You'll see their application ID is underlined, and they're identical, so that kind of shows you that there's like there's an enterprise, or there's a foreign key join between those two resources, basically. So they are, in effect, one and the same thing. But then you'll see the object ID is different for each of the resources, so that shows you that they're separate things. So they're one and the same entity, but also separate. You'll sometimes see, you'll be logging in with the app, with the service principal, and you'll see the object ID of the enterprise application appear, when it's actually authenticating the app registration. So there's some confusion there, and it took me a little while to figure out what actually was going on there, and it's understanding that enterprise application is kind of being authorized to access something, and authentication actually works through the app registration. So you're able to authorize, you're able to authenticate correctly, but the authorization doesn't allow you to carry on. So what and why do we use service principals? Back in the good old days of on-prem, we used to create service accounts or fake users. So you would go to Active Directory, you'd go and create a fake user, and then that fake user would be able to access things maybe through group policy, for example, or maybe through roles on SQL Server instances. You've got the different types of roles. You go and add a user to those specific roles. And service principals essentially replace what those fake users or service accounts used to do. So I feel that service principals are problematic, and the reason I find them problematic is, firstly, there's that admin overhead. It has to be created. The client ID and the secret needs to be created. Then there's the application team that needs to go and consume that ID and that secret. So there's a bit of a process, a bit of an overhead there with going and creating something. And at some point, that client ID or that secret is going to be exposed to someone somewhere. Even if it's stored securely in Key Vault, someone might be able to go and access it. And it's not just stored in Key Vault, it's probably going to be stored in lots of different places. Applications are going to use the same service principal. Lots of apps might use the same service principles. It's stored in lots of disparate places. You're not quite sure where it's stored. And then there's the challenge of updating it, because secrets have expiry dates on them. They tend to be like 1 or 2 years. Find lots of companies do 1 or 2 years, and the reason they do it is because updating that sensitive information is hard, because the team that goes and creates it is not the team that actually goes and uses it. So if you're thinking, well, I can just automate that process of updating secrets, you absolutely can. I'm not going to say that you can't. But it's quite difficult, it's quite challenging. You need an awful lot of permissions across in Azure Active Directory as well as across Azure resources to be able to go and update it. You need to know where it's going to be updated. So if you want to go and automate it, I would suggest that you go and refresh your secrets like every 2 weeks, as opposed to every 1 or 2 years, because then you'll get good at automating that process. But most people set it at 1 or 2 years, and then it's not a problem that becomes a need to be automated. And I also find there's like a bit of an infinite loop here of the fact that you want to store secrets in Azure Key Vault. So, okay, so I'm going to deploy them from Azure DevOps, which is fine. And you can go and deploy them as, as a secret in Azure DevOps. Then you can store them as a secret library in Azure DevOps, but then it's difficult to update Azure DevOps. So then you go and store it in Azure Key Vault in order to have it as a library in Azure DevOps. But then you need to go and get that other Key Vault. So deploy it using Azure DevOps. And then you deploy the Key Vault. And I just don't feel that there's like a satisfactory story for going and getting secrets and storing them in Key Vault and how they're deployed and how they're managed. And I think storing secrets is a pain. So this is where I turn the floor to you guys. Those of you at home as well, you're free to join in. Basically, I feel that storing secrets is a pain. I'd like to gauge the room's kind of feeling on whether it really is a pain or whether I'm just really overthinking the problem here. It'd be interesting to get people's thoughts on this. Maybe. Okay. I'll give you like 20, 30 seconds to go and vote on this. Okay, let's move on. Okay, some people agree, some people are sitting on the fence. One person doesn't agree. That's fine. The thing here is that as long as secrets are stored securely, then it's not a problem, right? As long as we can update them, then, it's fine. I think the problem here is the fact that secrets aren't really that secure. So on the right, this is a step in Azure DevOps. So this is taking a secret variable, password, and then what I'm doing is I'm just, for each character within the value stored within that secret variable, I'm just printing it out onto the screen there. So I'm actually able to expose the value of the secret through Azure DevOps there, quite simply. It's not really a problem. It's a great way of finding, if you've ever lost a secret variable, just go and do this. It's a great way of figuring out what the problem is. And this works for Azure Key Vault as well. If you've got an Azure Key Vault backed Azure DevOps secret, you can go and print out the value of it really easily. And that's not just for Azure DevOps. This is an Azure Databricks notebook. I'm essentially doing the same thing, but in Python here. I've got a Databricks-backed secret. It's the same for Azure Key Vault secrets. For each value, or for each character within the value of the variable, I'm just printing it out onto the screen there. And you can see at the bottom there, lines 10 and 11, I'm printing out the variable, and you can see at the very bottom there, it comes out as redacted. So what should be printed is redacted. What's actually printed is the value of the variable. So secrets really are only as secure as the weakest point, which, if you can go and expose the values of it quite simply, then I think that's quite a problem. So where do managed identities fit into this? So managed identities is basically 100% identical to service principals. Where you use service principals, you can use managed identities. The key here is when you go and create a managed identity, all you go and create is the enterprise application side of it. There's no app registration side of it at all. Rather, what happens there is the enterprise application is linked to a resource in Azure, so a VM, for example, or an ADF. And Microsoft haven't exposed exactly how it actually works, but there's basically a certificate that exists for that Azure resource that's valid for 90 days and refreshed every 40 days automatically. So you have to do nothing. So that's really kind of focusing that. It is a managed identity. And so how do we enable managed identities? Because they sound quite interesting. For ADFs, you do absolutely nothing. When you create an ADF, there's a system-assigned managed identity. There's two types. There's system-assigned and user-assigned managed identity, but I'm just going to talk about system-assigned because time is short. For other resources, you can use the portal, the good old portal. You just basically find the resource that you want, filter by identity, and then you've got a tab there. You just go and assign system-assigned managed identity, go and save it. It's about a 10-second job. You can also use Terraform as well. I'm sure you could do this in Bicep and ARM and all the other Azure CLI and Azure PowerShell and all that. Basically, you see the snippet there of a Azure VM being created with a system-assigned managed identity created alongside with it straight away. So if you have a VM that's got system-assigned managed identity, you can quite easily go and deploy everything from that Azure DevOps server because it's got a managed identity against it. So really, there's no need for service principals. This here is an ADF in the enterprise application registry. So what's happening here is the fact that we can see that it's an entry in the enterprise application, and then you've got the application ID there. Now, I said earlier that application ID is like a foreign key to the enterprise application and the app registration. So if we go to the app registration entry and search for it via the app ID of the enterprise application, there's absolutely nothing there. So if this was a service principal, you'd see an app registration there, but because it's a managed identity, there's absolutely nothing. So let's talk about a scenario where a managed identity would be really useful. So let's connect an ADF to an Azure Databricks workspace, and let's take a look at the options that you've got there. The first option is to use an Azure Databricks bearer token. So a bearer token is assigned to a user. So you can log into an Azure Databricks workspace, you can go and create a bearer token against a user, and then you come to the linked service to connect to the Azure Databricks workspace in ADF. Go and enter the access key, press save, done. It's nice, simple, quick, no issues there. It works. The challenge is, from a security perspective, is the fact that I don't know the expiry date of that bearer token, because it could well have an expiry date. I don't know who created this bearer token, because it's linked against the user. I don't really know where it's stored. I don't really know how to update it. I don't really know how to deploy it from Azure DevOps or any other kind of place. I don't really know where that is. And I mean, this is fine to get started, but really what you want to do is to kind of do better when it comes to the security, and there's better options. And another option is to add the bearer token to the key vault. So same process, you go and create an Azure Databricks bearer token against the user. You go to a key vault, you go and create a secret, and then the ADF managed identity needs to have access to that Azure key vault. So you need to go and update the RBAC permissions in the Azure key vault. Then you need to add the access policy so that the ADF can go and access secrets, because then it's got access to all the secrets. So that's a bit of a security issue there, I feel. And then you come into the linked service, you go create it against the Azure Databricks workspace, you select the Azure Key Vault, you select the name of the secret that contains the bearer token, and off you go. So this is better because you can set an expiry date against the secret in Key Vault. So then you can have the corresponding expiry date in the bearer token on the workspace as you can in Key Vault. You've still got the fact that there's a user creating it, and you know you can't rely that expiry date is going to be absolutely correct. So there's a third and final option. Like if you've got a managed identity to access Key Vault, why don't you just use that managed identity of ADF to go and connect exactly to the Databricks workspace? So it's nice, simple, straightforward. And then you've actually got two options here. So the first option here is to use the contributor role on the Azure Databricks workspace. So I'm adding the managed identity here to the Azure Databricks workspace as a contributor role, and then automatically the ADF get access to the Databricks workspace. Some companies, however, they don't really like you having access to the contributor role because, as I said earlier, it is quite powerful. It can cause some problems. So the alternative here is to use the Azure Databricks API. There's an option to go and add a service principal through the API. But of course, we're not adding a service principal. What we're actually adding is a managed identity. So this really kind of emphasizes the point that a managed identity and a service principal are fundamentally the same thing. There's no difference there. So it's really quite straightforward. And then you've got the advantage of using a managed identity. So when you look through the logs, if you're using a bearer token, whoever generated that bearer token, that's the name of that user that's going to appear in the logs for who went and executed this thing. So it can make it difficult to filter out who actually used it. With the managed identity option, you'll actually see the name of the ADF appearing in the log, so you can actually identify what was automated, who accessed it. It's really quite useful. So, that comes to the end of my session. Like I said, I don't think we're going to have time for questions. This is the feedback link. The organisers are really keen on hearing feedback from the people that attend the sessions. They'd really appreciate to hear what you've got to say. I'll be about for a little bit afterwards if people want to come and have a conversation with me. But otherwise than that, thank you very much for attending.